In the last section of 2.4, as I mentioned previously, we will be discussing how the complex numbers are related to our initial discussion of polynomials. But first, I really need to take a little journey aside and remind you all of something. We talked previously a little bit about simplifying radicals, so square roots basically. But I want to remind you of that here and how that works with negative numbers. So to begin with, let's just go ahead and take a look at something like the square root of 50. Now the square root of 50 is not in simplest radical form. Because there's actually a squared within 50. So let's take a look here. If I were to break 50 up into its factors, maybe 2 and 25 to start with, or you might do 5 and 10 first. And then we keep going, take it down to 2, 5, and 5. This is now in its prime factorization, so 50 would equal 2 times 5 times 5. All of those numbers are now prime. And you'll notice we could actually rewrite this as 2 times 5 squared. Well, this just tells me that when I have the square root of 50, I actually have the square root of 2 times 5 squared. And because this squared is underneath the square root, we can really simplify that. So we could rewrite this as, we can take out that square root of 5 squared, which is just 5. And then we're left with the square root of 2 under the radical, and most of the time we just leave it like this. So if you were to write the square root of 50 in simplest radical form, you would actually have 5 times the square root of 2. Now the reason for this is because if I have the square root of two numbers being multiplied, you can actually break that square root up over each of those numbers. And this actually comes from exponent rules, which I'm not going to go through all the proofs of today because it's not necessary. But if you want to learn more about that, it's because of exponent rules that we can do that. Okay, let's just do one more example. So if I had the square root of 8, well, this is the square root of 8 is really 2 times 4. And I know that the square root of 4 is 2, so I'm going to take that out. And we would have 2 root 2 in simplest radical form. So simplest radical form used to be a lot more emphasized in math classes. Most math teachers required students to write their answers in simplest radical form. I don't really care too much either way if you leave it or reduce it, because your calculator can do most of this for you. However, you should be aware that the two exist because it will come up in other math courses, and it could also come up on standardized tests. You might have to write your answer in simplest radical form. Okay. So let's go ahead and go back now to imaginary numbers or complex numbers. And let's do the same thing. So let's say I had the square root of negative 8 now. Well, we already talked about the square root of 8, but this negative 1 causes some issues. So let me break this up as square root of negative 1 times the square root of 8. Now the square root of negative 1, well, that's just I. The square root of 8 was 2 root 2. And so what I would write is this is actually 2 times the square root of 2, and then I. Notice I is outside of the square root. That's why I put the little bar going down. If you don't like this, you could rewrite it as I 2 root 2, just to make sure that the I is not underneath the square root. But this way is better because remember, the complex numbers in general form is A plus B, and the I usually comes last. It doesn't always, but oftentimes it does. So it's better to write it this way. Let's take a look at another example. So let's do the square root of negative 54. What I'm going to start off by doing is just to remind myself, I'm going to put that I out front, and then I'm going to think about 54. So 54, the first thing that comes to mind is that this would be 2 times 27. I don't have any perfect squareds yet, so let's break up 27. Well, that's 3 times 9. Now I do know that 9 is a perfect square because the square root of 9 is 3. And then I'm left with the 2 and the 3 under the square root. So that means that the square root of 54 is going to be 3, or the square root of 9, and then I'm left with the square root of 6. So that's that 2 times 3. So then my final answer over here would be 3 times the square root of 6, and then I outside the parentheses. Okay, so that was just a quick review on radicals. The next topic I want to discuss, but again, before we get back to polynomials, is I really want to focus on this idea of the simplest form or general form for a complex number, in particular when there's a fraction. Now, once again, part of this is due to you will see different ways of writing this no matter where you are in math class on a standardized test. But more immediately for us, this is going to show up in Delta Math. Delta Math requires that you write your answer in the simplest form or simplest radical form as well. So let's just say, for example, you were given, let's say you did all this work and you ended up with an answer that looks like this. 8 plus the square root of negative 16 all over 6. Now, you did everything right. Let's say this was the correct answer. And you'll see how we might get an answer like this in just a moment. But let's say you got this. This was your correct answer. Now, there's a lot of stuff going on. First of all, what I notice is that this can actually be reduced because the square root of 16 is 4 and the square root of negative 1 is I. So that means that this is just going to give me 4i. I also noticed that that 8 and that 6 can be reduced as a fraction, but let's first worry about that 4i. So I would end up with 8 plus 4i over 6. Now with fractions, you're going to want to distribute that 6 to each term in the numerator. So this is really what I'm looking at. I can't just give the 6 to the 8. I have to give it to the 8 and to the 4. Reducing this, I think I can divide everything through by 2. I would end up with 4/3 plus 2i over 3. And so this would really be my final answer in kind of the general form for complex numbers. Alternatively, you could leave it like this, even though this isn't quite the general form because we really ought to have 2 separate components to an imaginary number. This is also okay, but the circled version is really the better version here.